Okay, got the Cobra 2000 GTL partially done now. The frequency counter module you had seen me do in the previous video, that's been reinstalled here. So there's the one just redid. And remember, we installed that diode right there, right to the right of my finger. The lid back on here. I'm kind of biding my time at the moment. I'm waiting for everything to warm up so I can do the alignment, which the counter is already starting to warm up. I can feel the lid's getting warm. So in any case, the reason we installed that diode was time. Hit the time button there, get it counting. So there, you can see we now have 2 extra digits that count seconds. So that's what installing that little diode in there does. If that's something you want to do, like I say, pretty much anybody can do that. You don't have to even take the module out. The only thing you need to do is make sure your unit's unplugged, turned off, so you're not operating on a on a live chassis. But like I say, just basically put 2 dots of solder on those 2 empty solder pads I showed in a previous video, and install the diode like I show, and you will have seconds display on your clock. So I've still got to clean this thing up. It's still dirty. And from the looks of it, I'd say, especially the controls. I just got done cleaning the controls, and I just got done spending probably the last, God, I don't know, 15 minutes cleaning these switches. Oh my God, were they ever dirty. This poor speaker switch. Yeah, I could kind of hear. 2 was fine. It was in the middle, and then you went up to 1. It was just, it just shut off. You could barely hear anything. And I spray it and clean it and move it back and forth. My God, like I said, all of them were dirty. But yeah, that took quite a bit of cleaner in there to get these so they're nice and static free and make good contact every time. But all the controls were clean because they were all nasty. I mean, my God, the volume control was to the point where you almost had to have the volume up the whole way before it would you start to hear a little bit of crackling. Microphone, they were all just. So if I had to take a guess, I'd say this radio hasn't been used in, God, probably 10 years or more, which is a good thing. It means it's low hours. You know, it's the more time it's been turned off, the better. But yeah, and it definitely has a coating of dirt on the faceplate. I can see that should clean up fairly well. It's kind of very dull right now, so like I said, that should clean up nicely. Inside, got all the electrolytic capacitor. I still have to tie, like I say, I'm not completely done yet. Just you know, I'm to the point now where all the caps have been changed. I'm going to do the alignment, and when I get finalize everything, I'll make sure everything's nice and neatly wire tied. Now, one thing I suggest on these radios, you don't have to do it if it doesn't need it. In this radio, I did do it. The thermal grease, or thermal heat transfer grease, was fairly dry and crunchy on all the semiconductors that mount to the heatsink. So you've got a bridge rectifier right here, okay? And you've got your driver, final, your bias diodes, and your audio amp and power regulation circuits over here. So the easiest way to do these, now this one's easy, just take the screw out. And in this one, it happens. The screw hole stripped out because it's just threaded into the aluminum, so it just now has a little bit longer screw with a nut on it. But the easiest way to do these transistors and ICs along here is just remove this plate. So there's 2 screws down here and then 3 along the back side. Now, trying to get down in there and get the screws sometimes can be a little bit tricky. So here's a little trick for you. I've had one of these things since I was probably, I don't know, probably 9-10 years old, when I had, probably not long after I got my first screwdriver, is a magnetizer demagnetizer. I've got my original one from when I was a kid out in the garage floating around somewhere. I've got these things everywhere. I love them. But use this side to magnetize your screwdriver. Then the screws will stick to the tip. So when you take them out, they'll be stuck on the tip of your screwdriver. When you go to put them back in, it makes a great screw starter. But take this off. Now, from the factory they did it, so when I reinstall it, I do the same thing. They actually put heat transfer grease on the heat sink between it and the chassis. So you see it's smushed out down there a little bit. So before you reinstall this plate, remove it, clean everything off really well, and then apply new thermal heat transfer grease to the bottom side. And what that does is any heat is absorbed by the heatsink plate, which it's designed to do, not only can be just dissipated off of it, but it can also be transferred down into the chassis and, again, out into the atmosphere, because cool semiconductors are happy semiconductors. A few other things on these chassis. I could rant for hours or days, probably, on some of the useless, how should we say, BS I see people do to these radios. And a lot of it's just customers being overcharged for shit they don't need. It's basically what it comes down to. A lot of people, I'm not going to say they're being ripped off, because the work that's being done, it's a fair price. The problem is the work that's being done does not need to be done. It's a waste of money. One big thing I see is power supply circuits. I see people, for putting all these bigger transistors in or beefing up the power supply circuits and whatnot. Why? Regulator circuits. What's the purpose? This radio has absolutely no use for it. This power supply in this radio has been humming along since, I think this one was made in 1990. I think the date on the ID label on the back has been humming along since the 90s just fine. So a couple decades, this thing's been working just fine. And you know something? It still works fine. Works a lot better now that it has new caps and everything's been cleaned up. But the only thing that I upgraded in the power supply circuit was the main filter cap right here, okay? Was upgraded from a 4700 to a 10,000 microfarad. That's the only thing I did. It doesn't need any more than that. A few other capacitors in here were upgraded in size, some of the larger ones you see in here. And basically, in layman's terms, for all intents and purposes, these are filter caps, but they're also basically batteries. That's basically what this is. It's a short-term battery. This can store a charge. Okay, that's what an electrolytic capacitor does. It stores a charge, and if power supply rail voltage should happen to drop, there's the transmit circuit all of a sudden has a snap need for a little bit of extra voltage. There's a large current draw, and the power supply can't catch up to it fast enough. The capacitor can then give up its charge. And it also takes ripple out of your AC, because there's always some ripple coming out of your bridge rectifier circuit, so the filter cap helps to absorb that ripple and level the circuit out. So like I say, you just upgrade a couple of the filter caps in this thing. It's all you really need to do. Anything else, honestly, is a waste of money. The only reason you would need a heavier duty power supply would be if you're trying to get crazy amounts of power out of one of these radios, and again, waste of money. For starters, this power supply was designed as a whole circuit to provide a certain set amount of power. Increasing the capacity of a lot of the transistors and parts in this part of the circuit, well, that's only part of the circuit. That's great if the transistors can now handle, a higher current load. People seem to forget there's one limiting factor to this equation, and that's this chunk of iron right here. That's the power transformer, okay? Turns your AC line voltage right here into DC, into the bridge rectifier, and then into your radio. So, yeah, you can increase this all you want. Hell, you can have add a whole line of transistors, make this a huge circuit. Could supply 1,000 amps. You get past the power that this thing's rated for, you'll just smoke your transformer. So, waste of money. Like I said, you don't need it though. All these modifications you see people doing in these radios, clipping modulation limiters, disabling the AMC, ALC circuits, trying to get crazy amounts of power out of this. It's a single final radio, people. That one little 1969 transistor can only do so much. You cannot expect it to do anything more. You get to a point, once it's fully saturated, you're going to get distortion. And you're going to end up with high levels of second, third, fourth harmonics. You'll end up with third order products, adjacent channel splatter. A lot of the power, especially when you start messing with the modulation circuit, a lot of that extra power you're getting is no longer on the channel that you're on. If the power is not on the channel that you're on, it's not doing you any good. Now, it may look fantastic on a watt meter, but the person on the other end trying to listen to you doesn't care what your watt meter shows. He cares what is coming out of his speaker. So, save your money. And probably more importantly, save your radio. When you hot rod your radios like that, the only thing you're doing is increasing the likelihood that you're going to have parts failures. So you're shortening the life of your radio. The driver and transistor in this radio are factory original. They've never been removed, so they've factory solder. I can look at the solder on those. They've never been touched. You know something? 20, 25, 30 years from now, as long as this radio is left alone as it is, once I get done aligning it, those two transistors will probably still be in here and working just fine. If you go try to get maximum smoke out of them, that's exactly what you're going to do. You're going to get smoke, and once you let the magic smoke out, it's expensive to put back in. So, keep it reasonable, people. There's a few minor modifications you can do to these radios to improve performance a little bit. Like I say, increase the size of some of your filter capacitors, gives certain parts of the circuits, basically a little bit better reserve capacity for power and whatnot. You can install Schottky diodes, these little blue guys down there, do a little bit of work in the receiver circuit. Other than that, you don't need to do anything. These are good radios. They have good reception and transmit out of the box. That's why they're a popular chassis. So, don't go hog wild. You get an old radio like this in decent condition, just do a cap job on it usually. Remove the crappy-ass conductive glue out of these things. Now, it's all been removed where it needs to be removed. Now, you will probably, I don't know if you can see it or not, but there is still some of that glue in here. It doesn't need to be removed because it's not actually touching any components, anything that it can damage. There's still a blob of it right here. There's still a little blob of it right here. There's a little blob of it right there, and a little piece right there. But notice it's not down touching any of the leads, down the VCO block. There's, the only thing it's touching here is the top of this transistor and the top of this transformer can. The only thing it's touching here is the transformer can and the top of the ceramic filter. So it's not touching the components, so you don't have to worry about it shorting out, when it becomes conductive or corroding the leads off of parts. Anywhere where it needed to be removed, it was touching components, like back here on all these ferrite beads. There's always some on these two little capacitors here, always have some that's been removed. Anywhere it was touching components, leads, where it's touching the copper leads, it was removed. So, those are the things you want to do. Check your heatsink grease to make sure it's still nice and juicy, because if it's dried out, once that gets to the point where it's just basically dust, you can just scrape it off because it's rock hard. It's not performing like it should be anymore. So you're not getting good thermal transfer to your heatsink plates. Recap them, a little bit of mild work. That's all you need to do, and a good proper alignment on these, and you'll have a good, clean running radio. Don't try and get crazy watts out of it, because those crazy watts only are good. Like I say, they look good on a watt meter, and that's it. They sound like shit on air. Pardon my French, but it sounds like shit on air, and it looks like hell on a scope, and looks like even worse on the spectrum analyzer. Maybe at some point what I'll do is, I really need to show how horrible the audio quality difference and how bad it is spectrally, looking at it in the RF spectrum, how bad doing a lot of those modifications is. So maybe one of these days I'll get like a brand new radio. I don't know, like a Cobra 29 or something. The new ones are pieces of junk. I'll try and get one made 2010 or before that's never been modified, show you what a basically out of the box stock radio looks like, what it looks like with a proper alignment. Yeah, you can get a little bit more power and still be clean and sound even better, and then do all those crazy modifications that everybody does, and show you how your audio quality has decreased. Yeah, it won't increase. Everybody say, oh, you sound loud and proud. Well, actually, you sound like shit. And the reason you do is because you'll hear a lot of people say your waveform's box card or your clipping. Well, when you look at it on an oscilloscope, instead of having nice rounded tops to your waveform, that's what it does. It flat tops or box cards. It'll just look like little boxes on the scope. And that's lost audio. And that lost audio ends up usually in, like I say, third order products. It ends up all over the RF spectrum, but it doesn't end up on the channel that you're on. So, if the power is not where the channel is not on the channel that you're on, it's obviously not doing you any good. So, like I say, there's a little gripe for me. So I'll get the alignment done on this, and probably do do a little continuation on this this video. Show what it looks like properly aligned. I'll show you, on the scope what a proper waveform pattern looks like. Modulation package looks like. What it looks like on a spectrum analyzer. Basically, it should be a flat line with only a spike on the channel that you're on. Do some audio measurements. We can show you the receive sensitivity. Take some synad measurements of the receiver. See how sensitive it is. So I'll, like I say, tack on a little piece to this after I get it done and get it cleaned up. Like I say, because right now it's still filled. The inside's been cleaned up, but the outside's still pretty nasty. It may not show up on camera, but trust me, it is.